On the job, it's likely that you routinely handle several kinds of hazardous substances. Flammable and toxic materials are so common, we often aren't conscious enough of their potential dangers. Even in our private lives, we handle hazardous substances routinely. Safety precautions become a matter of habit. That means we're aware of potential dangers and know the procedures that minimize risks. For example, we know that gasoline is a hazardous substance. It's flammable, even explosive. But we also know that handling gasoline can be safe if we use the right precautions. On the job, the hazardous substances you come in contact with may be quite a bit more exotic than the ones you use at home. Here at the plant, a lot of chemicals that we use constructively every day are extremely hazardous unless they're handled the right way. We're going to be talking about many of these hazardous substances. We're going to see why they're dangerous, what their effects are, and what precautions we can take to reduce hazards. Now, for the purpose of this discussion, we can group hazardous substances into three categories according to their effects: toxic or poisonous substances, flammable substances, and radioactive hazards. You'll find that many substances seem to overlap two of these groups. That is, some substances are flammable and toxic, or they're radioactive and toxic at the same time. A little later on, we'll discuss each of these groups in detail, but first, let's get a general view of each category. First, we've got toxic hazards, like chlorine. Now, toxic hazards are poisonous. They can cause death or injury when they're breathed or swallowed. Some even poison you when they're absorbed through the skin. Now, obviously some poisons are going to be stronger than others. The most hazardous toxic substances, or even a small exposure would cause injury or death, are called acute hazards. Chlorine gas causes acute poisoning. The effect is immediate. Other toxic substances aren't dangerous until they've begun to build up to a certain level in the body. Now, these are called chronic hazards. Only repeated exposure over time produces the toxic effect. For example, people who work unprotected around silica dust or asbestos fibers will show the effects of chronic poisoning only after years of exposure. And by then, it's often too late. Our second group of hazards is flammable substances. Any material that catches fire easily is considered to be flammable. Flammable liquids, like solvents and gasoline, have to be handled carefully to prevent fire hazards. But there's another problem, too. Almost all flammable liquids are also toxic to some degree. Vapors from solvents can cause acute poisoning, especially when used in a poorly ventilated area. Now, coal dust can be extremely flammable, even explosive, when it's spread through the air. And like other flammable substances, it's also toxic. Breathing coal dust over a period of years causes a chronic lung disease called black lung. Many flammable substances require double precautions. Fire prevention is important, of course. Sparks or flames should be kept away from any flammable substance. But just as important are the precautions that help keep flammable substances out of your lungs and off your skin. A little later on, we'll discuss the precautions and procedures to use when handling toxic and flammable substances. But before we do that, let's take a look at our third group of hazards, radioactive materials. Like the other hazardous substances we've discussed, radioactive materials can be dangerous in several ways. Chronic exposure to low-level radiation can cause cancer or other diseases over a period of years. But acute exposure to high levels of radiation can kill directly. Preventing exposure to radioactive dusts is important for two reasons. First, there's the radiation hazard. And second, many radioactive materials are chemically toxic. If particles of metallic uranium or plutonium were breathed or swallowed, their toxic effects would harm the person long before the radiation would. I don't want to make you uneasy, but the truth is we're surrounded by hazardous substances both on and off the job. Luckily, they're not all as dangerous as plutonium. In the next few segments, we're going to be talking about the hazardous substances you use at work. We'll examine each one in detail and see why it's hazardous. We'll be discussing each one of the three groups of hazardous substances. We'll look at toxic hazards, poisons whose effects can be either acute, that is immediate, or chronic, where long-term exposure is the hazard. We'll discuss flammable substances, materials that can cause fires or explosions. And we'll take a look at radioactive hazards and the equipment and precautions we use to reduce risks of exposure to radiation. Now, as we discuss each of these substances, I want you to pay special attention to those that are regularly used in your work. Your instructor will point out the types of hazardous materials that you may be exposed to on the job. In a few minutes, we'll discuss several hazards one by one. But first, take this opportunity to read through segment 1 of your text and work the exercises, okay? So far, we've seen that many substances, ones we use every day, can be extremely dangerous when misused. We talked about toxic hazards, flammable materials, and radioactive substances. And we've learned that the effects of these substances can be either immediate or delayed. Now, when effects are delayed, that is when the substance takes time to build up in the victim's body, they're called chronic effects. When the body reaction is immediate and severe, this is an acute effect. Now, there are many different kinds of substances that can cause health hazards. Too many for us to discuss here, as a matter of fact. So what we're going to do is look at the ones that will probably be important to you, those substances that are the most common and the most dangerous. To start out, we'll discuss some acutely hazardous substances. And we'll begin with one that all of us are exposed to every day: chlorine. Chlorine is used for a variety of purposes. In swimming pools, chlorine kills algae and germs, helping to keep water clear and safe. Drinking water is also processed with chlorine to kill disease-bearing microorganisms. In the home, laundry bleach is the most common use of chlorine. In industry, chlorine is used to bleach paper, process plastics, and treat water. Since chlorine is so widely used, you might assume that it's not a very dangerous substance. Unfortunately, that isn't the case. Chlorine is a highly corrosive gas. Yellow-green in color, it has a strong, bitter smell, like bleach, that provides ample warning of even the smallest leaks. When chlorine is transported or stored, it's usually compressed into a liquid. The liquefied chlorine can be stored in cylinders of any size, from tank cars all the way down to small bottles. Chlorine gas is approximately 2.5 times heavier than air. That means when a chlorine leak occurs, escaping gas tends to settle in low places like floors and shafts. Ammonia reacts with chlorine to make a thick white smoke. Chlorine also reacts with many other common substances. Hot iron or steel can react powerfully with chlorine. While chlorine is not flammable in itself, it does promote the combustion of certain materials. This pad's been soaked in kerosene. Kerosene and other hydrocarbons can create a violent reaction. It's a good idea to keep fuels and solvents away from areas where chlorine is used or stored. But what do you do if there is a leak? Well, you may not be able to see the gas at all, but you'll smell it and feel its effects. Severe exposure may cause you to pass out. Now, if someone's collapsed in the gas area, go in with breathing apparatus and take them out to fresh air. Prompt medical attention is vital when severe chlorine exposure is the problem. But there are several things you can do while you're waiting for the ambulance to arrive. Luckily, this victim's still breathing. Artificial respiration's not necessary. Giving oxygen is the best way to revive her. When she wakes up, it's a sudden shock. Often, victims struggle when they regain consciousness. Keep the mask on, even if you have to hold the person down. Get the victim to relax, rest, and take oxygen until medical help arrives. With prompt attention, most people recover from minor chlorine exposure with no permanent damage. But chlorine leaks are still serious health hazards. Let's see how leaks are located and stopped. The first thing to check is the tank valve. If it's open, shut it all the way. When the valve's closed, search for more leaks with a squeezed bottle of ammonia. As we saw earlier, ammonia and chlorine react to form a thick white smoke. Spray ammonia all around the valves, gas piping, and connections. A leak shows up as a trail of white smoke. By following the trail to its source, you can find the location of the leak. Then, you've got to stop it. This is Chlorine Emergency Kit A. It has 3 special devices for stopping leaks in 100 and 150-pound cylinders. This device stops valve leaks by capping the entire valve assembly. Chains secure the cap and compress its gaskets into a tight seal around the neck of the cylinder. When fusible plugs are the source of the leak, this device will temporarily clamp it shut in an emergency. Fusible plugs are a safety device. In a fire, they'll melt and release pressure so the tank doesn't go up like a bomb. Now, this patch is used to stop leaks in the side of the cylinder. Twisting the nut at the top tightens the chain, compressing the patch against the cylinder wall. Emergency Kit B has the same sort of devices for stopping leaks in ton containers. We even have kits for tank car leaks. This one's called Chlorine Emergency Kit C. One of the best things you can do to help prevent chlorine accidents is learn to recognize it. All chlorine containers should have a tag to identify them, like this one right here. Finally, you've got to know what to do in a chlorine emergency. First, evacuate the area. It may be necessary to enter the gas area with breathing apparatus to rescue people who've passed out. Bring them to fresh air, call an ambulance, and give them oxygen until medical help arrives. If victims have stopped breathing or there's no heartbeat, don't just stand there. Give artificial respiration. Where chlorine is used, there should always be someone who knows techniques of cardiopulmonary resuscitation. It's the only way to help somebody whose heart has stopped. When the people are taken care of, you have to find the leak using ammonia and stop it with one of the techniques we've just seen. Chlorine's a very common and a very dangerous industrial hazard. That's why it's especially important to be conscious of safety precautions and procedures for chlorine emergencies. Used safely, chlorine's a very useful substance. But when the gas gets loose, it can be a killer. Make sure you know what to do in an emergency. Now, in a short while, we'll be back to talk about some more hazardous substances. Many of them are just as common and just as dangerous as chlorine. But before we go on, read through segment 2 of your text and work the exercises. In the last segment, we discussed chlorine, and we talked about its effects. It's a corrosive gas. It tends to eat away at other materials or dissolve them. We're here now to talk about 2 types of substances that are also corrosive: acids and caustics. This tanker is filled with sulfuric acid. Sometimes it's called vitriolic acid. Like all acids, it's corrosive. and you have to take special precautions whenever you handle it. Acids, in either high or low concentrations, are used for lots of different purposes. Here, sulfuric acid is being used to neutralize chemical sediments from the plant's water treatment system. It's also used to regenerate resin bed filters that are part of the same system. You may be more familiar with sulfuric acid than you think. It's the acid used in car batteries. These are a few of the uses of sulfuric acid. To learn something about its effects, let's go to the lab. The bottle contains a concentrated solution of sulfuric acid. It's a thick, oily liquid, almost colorless, but kind of cloudy. In the beaker is an organic material made of wood pulp, an ordinary paper towel. First, the acid combines with the water in the paper fibers. Then the paper begins to char. In a short while, the paper has decomposed. The effect of strong acids is very similar to that of fire. The material burns, and all that's left is ash. Sulfuric acid reacts with other substances in much the same way. This demonstration shows the reaction between sulfuric acid and sugar. Only a small amount of acid is needed. A slight stir will help get it started. Within seconds, the sugar is charred and blackened. It's burning up, just like the paper did. But the sugar's doing something else, too. As the sugar decomposes, the reaction releases hydrogen gas. Many of the reactions of sulfuric acid release free hydrogen as a byproduct. It's a highly flammable gas. It can even be explosive. That's why it's a good idea to keep sparks and flames away from any area where sulfuric acid is used or stored, including batteries. Other acids have similar corrosive properties. Nitric acid, chromic acid, hydrochloric, and perchloric acids will all burn organic matter and corrode many metals and other substances. Let's watch as a few drops of perchloric acid are put on this leaf. In a few minutes, the leaf's black and charred. This type of reaction can also cause acid burns on your skin. Some acids pose other hazards as well. Concentrated hydrochloric acid sends up vapors that can burn your lungs, just like it chars a leaf or your skin. These acid vapors have an additional side effect. The corrosive action also works on your teeth. Some acids create breathing hazards when they react with other materials. In this demonstration, copper is being added to a solution of nitric acid. The reaction produced a highly toxic gas composed of oxides of nitrogen. Unfortunately, although inhaling the gas has deadly long-term effects, it gives you little or no warning. Its effects aren't immediately obvious. Chromic acid can also have severe effects without much of a warning. The chrome plating process is one of the most common uses of chromic acid. Above the vat, the air contains an acid mist. The pipe down the middle reduces the hazard by exhausting the mist through a vacuum line. But for full protection, respirators are the only answer. No protection can make you a candidate for cancer as well as chronic poisoning. Whenever you handle acid, you've got to protect yourself. Rubber gloves, rubber aprons, and eye protection help prevent burns from acid spills. But what happens if you do spill acid on yourself? Well, it won't eat your way quite this fast. But you've got to know where there's an emergency shower and eye wash station so you can wash away the acid. That will minimize its effect. Where large quantities are handled, or anywhere acid vapors may be present, respiratory protection is important. Gas masks or chemical cartridge respirators are available with canisters especially designed for acid gases. Now, if your job involves handling acids, make sure you have all the protective equipment you need and know how to use it correctly. With the right precautions and procedures, there's no need for anyone to be injured when handling corrosives. So far, we've looked at two different types of corrosive substances, chlorine and acids. There's one more class of substances that's also corrosive, caustics. Caustics, also called alkalis, are used right here in the water treatment ponds. Let's go down and take a look. Acids and caustics are both used here in the pond to neutralize chemicals from the water treatment system. That's because they're opposites. Although acids and caustics are both corrosive when used alone, they neutralize each other when they're mixed together. And when the runoff here is too alkaline, we add acid. When it's too acidic, we add alkalis. Calcium carbonate is one of the most common alkalis used. You probably know it as lime. It's corrosive. Inhaling lime dust can cause rapid lung damage, and caustic solutions can severely burn exposed skin. Let's go to the lab and see just what caustics can do. The beaker contains a 50% caustic solution, half sodium hydroxide and half water. For this demonstration, we're wasting some perfectly good ham. The meat reacts with caustic the same way your flesh does. Let's take a close look and see just what happens to the meat. Here, it's begun to dissolve. You can see that the meat's starting to break up, proteins being dissolved. Now the ham has dissolved even more. It's starting to spread out evenly through the solution. Finally, the meat is completely dissolved. The caustic's eaten away at it until there's not a solid piece left. Caustics do the same thing to you when they touch your skin. It's like you're instantly digested. Flesh, bone, hair, it doesn't matter. All that would be left is your teeth. The demonstration you just saw was with sodium hydroxide. It's one of the most powerful caustics around. There are several other caustics that are also fairly common. Phosphates are one. They're often used for water treatment just like lime and sodium hydroxide. Chromates are another family of caustics. They're used as corrosion inhibitors in paint and in water treatment systems. Chromates are extremely toxic. When you handle them in pure form or spray chromate paint, you've got to have a respirator. Whenever you work with caustics, use all the safety equipment you can. In general, you use the same protective clothing as you do for acids, a rubber apron and gloves, and eye protection. When there's a possibility of breathing caustic vapors, use the right kind of respiratory protection for the job. But most of all, be aware of what you're dealing with. When you know the hazards, you're halfway to being safe. The other half is using the correct procedures and being careful. Your instructor will be able to tell you what kinds of caustics are used at your plant. Learn what they are and where they're used. In a few minutes, we'll be back to talk about some substances that are hazardous in a very different way. Meanwhile, read segment 3 and answer the questions in your text. After that, your instructor will answer any questions that you have. A fire in the plant could be the most dangerous situation you'll ever encounter at work. But every day we handle substances that are capable of sending the whole place up in a puff of smoke. And those are flammable substances. Now, gasoline is one flammable substance we're all familiar with. And when we call it flammable, we're saying that it ignites easily. The reason it's so easy to burn is that the liquid gasoline sends up a lot of vapors. It's the vapors mixed with air that ignite, not the liquid itself. The more vapors it sends up, the easier a substance will ignite. Now, This leads us to two related hazards. First, in a confined space, the mixture of flammable vapors and air can be explosive. And second, the vapors may constitute a breathing hazard. Now, many solvents are just as flammable as fuel. They give off a lot of vapors. Some solvents are more hazardous than others. Methanol fumes can be deadly, even in small doses. Many solvents can poison your heart, your kidneys, your liver, if they're used in poorly ventilated areas. Fuel gases can be even more dangerous than liquid fuels and solvents. Natural gas is poisonous as well as explosive. Many other gaseous fuels like butane, propane, and acetylene are also poisonous in high concentrations. In general, it's safe to say that any flammable substance is poisonous if inhaled. Now, wearing the proper respiratory equipment is the best way to protect yourself. Now, we're not going to go into detail here because fire prevention is important enough to deserve a program all to itself. Right now, the important thing to remember is that almost all fuels and solvents will burn, and almost anything that'll burn will also explode under the right conditions. But there's one class of substances that's an exception to the rule. Those are fuels that don't burn, radioactive materials. Now, this may seem kind of exotic, but many radioactive substances are used in industry for X-ray testing, nuclear fuels, or experimental purposes. If you work around radioactive substances, you'll be monitored for your exposure to radiation. Small dosimeters and film badges are typically used. This whole body counter is one way to measure the amount of radioactive dust in your lungs. Inhaling radioactive dusts is a double hazard. Radiation breaks down the cells of your body, and many radioactive materials are powerful chemical poisons too. In fact, the toxic effects of metallic uranium are more immediately dangerous than the radiation hazard. When workers might be exposed to radioactive dusts in the air, special protective clothing and respiratory equipment are used to keep the particles off the skin and out of the lungs. But many radioactive materials are hazardous even when they're outside your body. Some substances emit enough radiation to hurt you even if you're some distance away. When this is the case, there are three ways you can protect yourself: shielding, distance, and time. Radiation shielding is made of dense, massive metals like lead. The metal absorbs the radiation, so very little gets through. Distance is another way of protecting yourself from radiation. The farther you are from the source of radiation, the less you receive. In fact, if you double the distance, you're only exposed to 1/4 as much radiation. Now, time is the third factor in reducing radiation. At this distance, the worker is receiving 100 units per hour. That means that if he stays 2 hours, he'll receive 200 units, and so on. If a certain job involves prolonged exposure, workers are often rotated to minimize the risk. If there are radiation hazards where you work, you'll be monitored regularly for radiation exposure, and you'll get training if you have to use special protective equipment. Remember, many radioactive substances are double hazards. They can harm you by radiation or by their toxic effects. Flammable substances are double hazards too. Fire is one danger, and like many radioactive materials, flammable substances are often toxic as well. Most of the precautions we've discussed are pretty simple. Your instructor will be able to tell you what hazards there are and what precautions to use in your work. Before going on to the next part, take some time for a class discussion and work through segment 4 of your text. A lot of different kinds of paints and adhesives are pretty dangerous unless they're used correctly. Now, any kind of paint is a breathing hazard when it's sprayed. Fumes from adhesives can be breathing hazards too, unless they're used in well-ventilated areas. I will be discussing several kinds of paints and adhesives in this segment. You'll see that some are far more dangerous than others. To begin, let's hear from someone who's learned a lot about epoxies the hard way.
This all started one Saturday last winter. I had finished building my Focke-Wulf here, and it came time to paint it. The manufacturer recommended that we paint it with epoxy paint. So I went out in the garage, turned on the heaters. Of course, the ventilation was poor. It was in the wintertime. And went ahead and mixed up my epoxy resin and hardener and got the paint ready to paint it. I went out in the garage and shot on the tack coat and waited the typical 25-30 minutes. Went back out, shot the final coat on it. It turned out real well. I went ahead and dumped out the remaining paint that I had, cleaned my equipment up and put it away. 30 minutes or so later, my daughter and I went out to the wood pile to pick up some firewood. Now, as I went outside, I noticed this smell of algae. You know, the kind of smell you might get from a pond or a mud puddle or something in the summertime. And I said to her, do you smell anything like algae? And she said, no. And it dawned on me that maybe I was the only one smelling it. And I got to thinking, well, you know, with some poisons, for instance, cyanide, you get that smell of almonds. So I got to thinking, well, maybe poison from epoxy will leave this algae smell. But then I didn't think any more about it and just went on. I suspect 2 hours or so later, from the actual time that I'd been spraying, I started developing these chest pains. It was kind of in my lower chest, and I had some soreness in my throat. And I got to thinking, well, shoot, I'd only been in the area maybe 4 or 5 minutes, the actual spray area. So I didn't pay it too much mind, but then the pains got worse and worse. So I said to my wife, you better call the ambulance and have me transported. So having a little medical background, I took the can that I'd used with me so that they could see the type of chemicals that are in it and, of course, offer some antidote. But when I got there in the intensive care unit, that's when I really got my education, because there is no antidote for epoxy poisoning. All they can do is treat you for some of your minor problems, like the sneezing or the pain. They can treat for those local problems. But the actual poisoning, there's no antidote for it. And the doctor in charge there said to me, he said, Tom, we're just going to have to wait and see. Well, fortunately enough for me, I hadn't reached my tolerance level, and I'm here to tell you about it. Whenever you use epoxy paints, whenever you spray epoxy paints, it should always be done in a well-ventilated area, preferably outside. You should always wear some type of protective mask over your nose and mouth so that you don't inhale any of the mist left from the painting. Another key point to remember is when you're doing your dry sanding. Oftentimes you forget to wear that mask and you inhale these epoxy dusts, which are equally as hazardous. Keep in mind that epoxy poisoning is accumulative, and that once you reach your tolerance level and then exceed it, you may die.
Tom Bain was lucky. Many epoxies in paints and in adhesives are extremely poisonous, and the epoxy paint he selected is one of the most dangerous kinds. Even the small exposure he got almost killed him. Not every epoxy has the same effects or the same symptoms, but they're all poisonous. Tom was exposed by breathing spray droplets. However, some of these substances are also dangerous when they're absorbed through the skin. Other types of paints can be hazardous too. Any spray paint is a breathing hazard if you don't wear a mask or have good ventilation. You're basically spray painting your lungs. Also, the solvents used in many paints may be poisonous. They can affect you through your skin as well as through your lungs. We've talked about solvents before. You know that they're breathing hazards. Well, whenever you're working with paints or adhesives, you're working with solvents. One exception is epoxies, but they're dangerous in their own way. Many of the solvents used in paints and adhesives are highly toxic. Some examples are adhesives containing toluene and xylene, and some of the adhesives used for acrylics. Workers are usually affected when they breathe the fumes. The most common immediate reaction is irritation of the eyes, nose, and throat. More exposure causes dizziness or nausea. And some fumes from paints and adhesives have acute effects like unconsciousness, hemorrhage, and damage to the heart or other organs of the body. Many of these substances also have chronic effects. Repeated exposure can cause brain damage, anemia, or cancer, even if dosages are low. The important point is, know what you're working with. Find out what's in the paints and adhesives you work with and learn how to use them safely. Your supervisor and your instructor can help you spot the hazards you'll be exposed to on the job. In a few minutes, we'll return to talk about some substances that are also breathing hazards. Meanwhile, read segment 5 of your text and work the exercises. You know, at just about any large plant, there are dusty areas. Now, back there, where we're running coal, it's pretty obvious that if you're not protected, you'll breathe in the dust. What we're going to be talking about here are dusts and gases that are hazardous. In most cases, they're breathing hazards, but some are dangerous in other ways, too. Coal dust is one of these double hazards. It's a breathing hazard, and believe it or not, it's an explosive hazard as well. Remember that we talked about flammable liquids that can be explosive when they send up a lot of vapors that mix with the air? Well, solids work the same way. If there's a lot of dust in the air in a confined space, the slightest spark can set it off like a bomb. Any burnable dust, grain, sawdust, or coal, will explode when mixed with air in the right proportions. But, as I mentioned before, many dusts are also breathing hazards. As a matter of fact, any dust can be irritating and potentially dangerous if you breathe enough of it. It clogs up your lungs. However, many dusts have more serious effects in smaller amounts. As we've seen before, epoxy dust and lime dust have acute effects. When you breathe them, they can cause immediate harm. The effects of other dusts usually show up only after repeated exposure. They're chronic hazards. Coal dust is a chronic hazard. If you're repeatedly exposed to high concentrations of coal dust, over a period of years, you'll develop black lung, the coal miner's disease. Now, when you've got black lung, your lungs have to work double time, but you still don't get enough air. The coal dust coats your lungs and veins, and oxygen can't get through to your cells. There are a couple of common dusts that can also have serious long-term effects: asbestos and silica. Sandblasting is where you're most likely to be exposed to silica dust. That's what sand is, silica. The chronic effect of breathing silica dust is called fibrosis of the lungs. Your lungs fill up with a stringy material and it's very hard to breathe. The best protection is an abrasive blasting respirator. Asbestos is found in many kinds of older insulation. It also causes fibrosis, but that's not all. Asbestos causes cancer. That's why it's seldom used in modern insulating materials. But when you're removing old insulation, wear a filter mask to be on the safe side. Now, these three dusts, coal, silica, and asbestos, are chronic hazards. It takes a long time for the effects to show up. On the other hand, dangerous gases tend to be acute hazards by their very nature. Since they're gases, they're inhaled and absorbed into the bloodstream just as easily as oxygen or any other component of normal air. If the gas is poisonous, the effect will be immediate. Now, we've already seen the effects of chlorine. Another well-known poisonous gas is carbon monoxide. Carbon monoxide is found in automobile exhaust. It's a product of incomplete combustion of fuel, whether it's gasoline, coal, oil, or any other fossil fuel. Unless combustion is perfect, carbon monoxide is formed. Now, this is often a problem when a cold boiler is being started up. As burning gases touch the cold walls, combustion stops before the gases are completely burned. Carbon monoxide is produced, and since it's hot, it tends to collect at the top of the boiler. Good ventilation is the best way to avoid carbon monoxide poisoning. Anywhere that burning takes place, whether it's a diesel engine or a boiler, is a potential source of carbon monoxide. If the area can't be adequately ventilated, you need a respirator. Carbon monoxide is especially dangerous because it prevents oxygen from getting to your cells, even though there's plenty of air in your lungs. If someone's been overcome by carbon monoxide, get them out into fresh air. Give them oxygen and keep them warm. If his breathing stopped, give artificial respiration and oxygen. Carbon monoxide is not the only gas that interferes with your oxygen supply. As a matter of fact, any gas, even if it's not poisonous, can knock you out and suffocate you if it displaces enough air. One example is carbon dioxide. It's not poisonous, it's a component of normal air. Here at the plant, we use it in fire extinguishers. Carbon dioxide is heavier than air, so it settles near the floor, making the air rise up out of the way. This is why an area's got to be well ventilated after this fixed system goes off. In a closed room, there won't be enough oxygen left in the air. Several other common gases act the same way. Nitrogen, argon, freon, and halon all sink down and displace air. The first two, nitrogen and argon, are normal atmospheric components. Freon and halon are part of a chemical family called halogenated hydrocarbons. Like nitrogen and argon, freon and halon aren't poisonous, but in high concentrations they'll displace air. Freon's used in air conditioning and refrigeration. Halon's used in this building's special fire extinguishing system. Now, these two gases present a special hazard. Although they're not poisonous, they can break down into deadly gas called phosgene when they're exposed to extreme heat. Now, that means that when halon's used to put out a fire, you may have poisonous phosgene gas in the area, as well as a lack of oxygen. Other substances also break down into toxic gases when they're burned. Plastic pipe is one example. Most plastic pipe is made of PVC, polyvinyl chloride. When PVC burns or melts, it releases phosgene. Now, this gas is so dangerous, it's been banned for use in warfare. It's just one more thing you have to look out for when you enter an area where there's been a fire. Hydrogen and oxygen can also be dangerous in fire situations. Neither hydrogen nor oxygen are poisonous at normal pressures, but hydrogen's explosive and oxygen promotes burning. Now, at this plant, we use hydrogen for cooling large generators. It's lighter than air, so it doesn't sink and displace oxygen. But if there's a hydrogen leak in an enclosed space, it pools up near the ceiling where any spark could set off an explosion. And that's one reason why these storage tanks are kept outside. Oxygen has different properties. It's the gas that supports life. If there's no oxygen in the air, you need to bring some along with a self-contained breathing apparatus. Normal air is about 20% oxygen, and at normal pressures, it's safe to breathe pure oxygen. Curiously enough, though, at double the normal atmospheric pressure, pure oxygen becomes poisonous, causing loss of coordination and possibly convulsions. Now, this probably won't be a concern of yours unless you're a scuba diver or a caisson worker. Then you'll have to avoid breathing pure oxygen and use air or another mixture of gases instead. Oxygen can be a greater hazard, though, in fires. This beaker contains air that's been enriched with oxygen. Watch as the smoldering cigarette's dropped in. Oxygen, although it doesn't burn, speeds up combustion, So the whole cigarette's consumed in seconds. You can see that in any oxygen atmosphere, even a small smoldering fire can quickly get out of control. In fact, oxygen can start a fire even without a spark. If pure oxygen's in contact with grease or other flammable substances, even a little bit of heat can start a fire. The heat from a hot piece of equipment might be enough. Now, fire is just one of the hazards to watch out for when you use compressed gases. Some, like chlorine and carbon monoxide, are immediately poisonous. Heavier than air gases like nitrogen and carbon dioxide sink and displace oxygen. And others like freon and halon become poisonous when exposed to heat. Now, we've also talked about dusts that are respiratory hazards. Coal dust, asbestos, and silica are three that cause chronic lung diseases. Remember, any breathing hazard can be avoided if you use the right respiratory equipment and use it correctly. If you're working with hazardous substances, it's to your benefit to learn what their effects can be and how to protect yourself. In a minute, we'll be moving on to another group of hazardous substances. But first, work through segment 6 of your text and ask your instructor what dangerous dusts and gases you have to be on the lookout for.
Heavy metals, such as lead, manganese, vapor from mercury vapor, are themselves systemic poisons and can damage your internal organs. Mercury itself will kill anything it touches. Inhaling them, unfortunately, appears to be the most efficient way of getting them into your body because they are spread throughout your system by the blood system. And as I said, they tend to concentrate in certain organs. Now, they are not poisons to the point that concentrations unless they're exceedingly high will kill you immediately, but they will build up in your body over a period of time because you can't get rid of them through the normal waste process, and they will eventually poison you.
Lead, manganese, and mercury are only a few of the hazardous metals we'll be talking about, but they're among the most dangerous of all metallic substances. As we go through the list of metallic poisons, we'll be looking at their acute and their chronic effects. As we just heard, it's usually the chronic effects we're worried about, the effects that take place over a long period of time after repeated exposure to the poison. We'll start with lead. Lead's a very common metal. It's used in solder, glass, ceramics, type metal, ammunition, paint, gasoline, and storage batteries, among other things. It's not exactly an exotic tropical poison, but swallowing lead or breathing fumes or dust from lead or lead oxides can be as dangerous as any of the substances we've discussed. The acute effects of lead poisoning include anemia, paralysis, brain damage, and possibly death. But acute poisoning requires a massive dose all at once. On the job, we're more concerned with the chronic effects of lead poisoning. After repeated exposures to small doses, lead accumulates in certain organs of the body, the liver, the kidney, and the brain. These are the areas that are first affected by the poison. Usually, lead poisoning first shows up as shaky hands and poor coordination. Later, as brain tissues continue to be damaged, the senses are dulled. Behavior may become bizarre, and the brain, the blood, and the digestive system become permanently damaged. Well, you might say that's pretty nasty, but how does it affect me? The answer is, you may be exposed to lead and not know it. Now, if you do soldering, lead casting, or salvage work on structures protected with lead paint, you are definitely exposed, and you may need some special protection, Respirators for lead can be almost 100% effective against lead poisoning if used correctly. That means you've got to have the right kind of cartridge in the mask. Now, this cartridge is specially designed for lead vapors. For different poisons, you'll need different cartridges. This one, for example, protects you from mercury vapors. Now, mercury has many of the same effects as lead, including brain damage, but it's a much more powerful poison. Even a small amount can be really harmful, and you can even absorb it through your skin. Mercury's unique among metals. It's a liquid at normal temperatures and pressures, and it vaporizes at room temperature too. The air in any place where mercury is used may contain mercury vapors. Now, we're all familiar with some of the uses of mercury. Thermometers and other instruments often have mercury to gauge temperatures or pressures. Mercury has a lot of other uses in industry too. Fluorescent lights and electronic components often contain mercury. It's used in electroplating, making chlorine and caustics, and refining gold. Like many other metals, mercury is also poisonous when it's combined with some other elements. Now, substances like mercuric nitrate are just as poisonous as the metal itself. Permanent liver, kidney, and brain damage can result from chronic exposures. The other poisonous metals also tend to attack specific organs of the body. Manganese attacks the nervous system, the brain, and motor controls. Like any poison that affects the nervous system, manganese can make you insane. Beryllium is another poisonous metal. It attacks the lungs. Workers in the electronics industry, where a lot of beryllium is used, may come down with chest pains, shortness of breath, heart damage, and even cancer, unless they're adequately protected. Even if you don't work in an industry where there are dangerous metals used, you may be exposed to another kind of metal poisoning, metal fume fever. When you're welding, breathing vapors from metals containing zinc or tin can cause intense fever and chills. Fumes from welding rods may even be more dangerous. If your welding area doesn't have good ventilation, you'll need a respirator to protect your lungs. Well, you can see that it's pretty hard to avoid exposure to poisonous metals. That's why you've got to know how to protect yourself from their effects. Often, good ventilation or breathing equipment is all you need. And remember that it's not just the metals themselves that are poisonous. Compounds that contain metals may also be deadly. Substances like silver nitrate, chromates, and cadmium salts all contain metals, and they're all poisonous. Other metals are hazardous in different ways. Some are especially dangerous because of the way they burn. Magnesium and zinc burn at extremely high temperatures, up in the thousands of degrees. It's not real easy to get them started, but once they start burning, they're very difficult to put out. You have to have a special fire extinguisher, Class D, because regular extinguishers may only make the fire burn hotter. Potassium and sodium also burn at very high temperatures, and when they burn, their fires are just as difficult to put out. But potassium and sodium fires start very easily. Sodium explodes on contact with water, and potassium ignites as soon as it hits the air. You can see that a fire hose won't do much good against this kind of fire. Again, you need a Class D fire extinguisher. Now, these metals have to be stored carefully, too. Sodium goes in a dry, watertight container, and potassium stored in kerosene to keep it out of the air. Well, we've discussed a lot of different kinds of metals and the hazards they present. Many of them are powerful poisons, especially chronic exposures. Lead, manganese, and mercury accumulate in your body and permanently damage specific organs, including the brain. Whenever you work around poisonous metals or any toxic, flammable, or radioactive materials, you've got to take advantage of the best protection available, and often the best protection is education. You've got to know what the hazards are, and how to protect yourself. Now, you won't be working with all of the hazardous substances we've discussed, but undoubtedly, you handle some of them every day. Gases, dusts, solvents, fuels, many other materials have built-in dangers. Your instructor and your supervisor will help you plan your work so risks are minimized. Remember, it's not some chart of accident rates that you have to worry about. It's you.